This
sure
conference
why.
will now be recorded.
Not sure why we had some problems. Let me jump to something real quick. Today, so I did kind of review it a couple minutes ago, and I'm not going to redo that. Let me see what I can share real quick. There's two topics that, well, we're working on two work streams. One I mentioned before was standardizing connections. The other was the concept of standardizing reference designs. And I'm going to share screens as I'm going through this, hopefully. Let's see. Okay. I probably should have handed this off to John. I do, as I go around the room, I greatly appreciate seeing people like Jason Rafkin, John Peterson, Jeremy Rice, and some Valley Sorrell, and people who've been great guidance for me in the past. And I may be tagging some of you as good, and John Gross also, and Dale Sarter, and Jack, and others. I'd like to first kind of go through these two work streams and share here.
Hey, Don.
Yes.
Can I ask you, let's say, a housekeeping question here? It would be very helpful if the people attending these meetings would share the companies they are with in their names.
Yeah, Don, it's super simple to do that. You go to, on your desktop, if you click on those three dots next to your name, there's a drop-down menu that comes up, and it says edit your name on it. And what you could do is put your first name and maybe your last initial, and then in parentheses, put your company's name. That really helps all of us. Just kind of affiliate, you with your company as well. And if you're an independent, you don't need to put anything down. I think it's just assumed, but I think that would really help.
Great lead-ins. So right now, are people seeing anything shared?
Yeah, we can see the top. Yep, we can see the top of your guidelines document.
So the two work streams I'm talking about here, one of the work streams is guidelines for connection of advanced cooling solutions for data center facility water systems. And then I also have saved on my menu, and by the way, everyone should have an invite to participate in these. And here is another item, which is data center liquid distribution and reference designs. And today I'm going to spend most of the time kind of talking about two topics associated with this topic here, which is the data center liquid guidance and reference designs. And there's two topics. We've gone through this. I'm not going to go through it in entirety. I would encourage, what I am looking to do is trying to connect or collect people that want to contribute to this document. And what you're seeing here are names so far. I would love to add other author, contributor, and editors. As we go through this, we look at the work stream here. The general guidance is that we're looking at a world where many data centers are now slab floors. We're looking at a world that's going to be adding liquid, not necessarily initial construction. My presumption with this paper is that we're trying to give advice on how to add. For those that are starting from scratch, there's a lot of unique and interesting ways to do a liquid-only data center. And some of that area might have benefit to looking at. But the challenge that we're trying to address is for many of our members, they have slab floor data centers with air-cooled IT, and sometime in the next 3 years, they're going to have to add liquid, or they may want to consider adding liquid. And we're trying to enable that in a simple fashion, recognizing that historically IT is refreshed every 3 to 5 years. So that's the challenge. So as you go through here, one thing I'd like to highlight is we got a input from down under. Mark Lomers is probably not on this call because I believe right now it is 2 a.m. in Perth, Perth, Australia. But what Mark did is he came through and he's made some comments here. I'm going to give Mark a separate call later on, and he's got a lot of questions of what we're doing. I would encourage anyone to make these comments, and this shows some areas that we're looking at expanding. In fact, John Minash, I may ping on you real quick. This is an area that we need to expand, which would be this chart here, which is a little old in the tooth and needs some adjustment. John, you want to give a comment real quick on what this chart is here for reminding people that?
I will try. I apologize. I'm in a kind of a loud area. Yeah, this is a chart that is intended to be able to give somebody an opportunity that is looking at their data center and saying, hey, I'd like to figure out how much cooling I can pull off of an existing pipe, for example. We have removed a crack unit, or we have stub outs available off of our existing chilled water system, or maybe condenser water system or processed water system. And what does that mean? So this basically takes and says, using a limit on flow rates, maxing out at a flow rate for a given pipe size, says at this pipe size, and then a given delta T, which is across the top, the theoretical max that you can pull for kW. So it's a ballpark, right? So you say, okay, well, I've got a DIN size 100 pipe, and I'm going to have a 6 degree C delta T. I could potentially get 332 kW. Now the actual number is going to be somewhat different and lower than that, based on actual performance and a whole bunch of other factors, but that does give you an idea of what you can implement. So that's the intent of this this chart.
That's great. And I just kind of want to introduce this as an example of one area we're looking at. And I'm going to go back to letting you see my animated face here as we go through. But a couple things you'll see here in the notes is there's a note that we want to change this chart to liters per second or something. There was a discussion from people in Europe that they, once again, the American group thinks that gallons is a great standard, but the reality is the rest of the world doesn't really use it as much. And in fact, there is some debate as to what a gallon is in certain parts of the world. So that would be an area of change. One area that I'd like to take advantage of the people that are on the call today, there's two areas. One is that we had this discussion on dew point. And if anyone has ever, well, let me I think I saw Jason on the call. And the key concern I have with dew point is condensation is one of the nefarious aspects of liquid pipes in data centers, okay? Not that condensation anywhere isn't bad, but pipes, generally because of their cold nature, can often operate below dew point for the given humidity of a data center. And why is that bad? Well, I don't want to scare you with videos and pictures, but if you ever search in the internet for images of corrosion under insulation, you'll see that it can happen even when you've insulated your pipe, that if you break your vapor barrier, it will corrode. So one of the questions that we definitely need to look at is if you're adding pipe or a liquid loop into a data center, you have several options. One option is that you maintain your dew point above, or the temperature of your pipe above dew point. Another is that if you can't guarantee the temperature of your pipe above dew point, that you put in some sort of protection to make sure you don't have condensation, or if you do have condensation, you're aware of it and you're draining it and it's not causing corrosion. I'd like to have someone else kind of jump in here. I know John Gross, you're online. Can you clarify the concerns I have here and maybe share them with others?
Yeah, I mean, it's really kind of, there's a couple bits to it. So, obviously if we're operating the piping below dew point, then we're going to have a vapor drive to the pipe, and we're going to generate condensation on the pipe, right? And that's really happening whether we've got the insulation or not. You and I talked last night about, do you put some leak detection cable, for example, underneath the insulation when you apply it. And, by my first reaction to that when we talked about it was, if you do that, you guarantee you're going to have an alarm, because it's, from what I've seen, all the different data centers, chiller plants, et cetera, that I've worked on over the years, somewhere along the line, somebody has breached the vapor barrier, whether it was during construction, where the system got energized before the insulation was on, which happens more than we like to admit. Somebody beat up the insulation during construction, or it got beaten up later on down the line. You're going to get some moisture underneath that insulation, but just because you've gotten moisture underneath the insulation doesn't necessarily mean you're going to run into CUI before the end of the life of the system. So the question then becomes, at what point do you actually have to act on it? And so I think that's the crux of the issue. Once we go and we put in the insulation on the pipe and we try to put a leak detector underneath it, what's our trigger point to actually pull the insulation off and do corrective action? And I think that's the hard thing to answer at this point.
And John and Don, I actually have a question. The problem, what is the real problem here? Is it the corrosion or the dripping of the water? Because if it is the corrosion, would go with plastic pipe be the solution?
Well, so a couple things on there. And by the way, I want to caution some people that the slides I'm about to show, you won't be able to unsee them, and they should not be viewed by people under age 18. They just scare the heck out. But so what you're looking at here, if you do that thing that I talked about before, is if you do look at corrosion under insulation, this is what can happen. Obviously, these are not a well-maintained data center environment, but this is just kind of to shock you as to what can happen if you don't pay attention to what's going on underneath. So plastic pipe could be, and I'm not going to share this too long because I'm not trying to discourage the use of metal pipe or carbon pipe or anything like that. I'm just highlighting the reason why we want to consider this as guidance. And plastic pipe is an option. Plastic pipe has its own dynamics. Does anyone else want to talk about the pros and cons of plastic pipe rather than listen to me? I can give some examples. It doesn't corrode as much, and it does have a better thermal resistance, if you will. One of the key disadvantages, it's got a lot of movement to it, and in many cases it has its own methods of failure that are different than steel and or carbon steel, and it's not used extensively to date inside data centers. There are places it is being used, and some of the methods of joining plastic pipe have some issues as well. But does anyone else want to comment?
Hi, Don here, Jaime from Climate Heat. With plastic pipes, we use them and we are pretty happy with them. Actually, you're very flexible for its installation, for adapting them together. You have different types of joints, and they're thermal resistant. They are usually not very expensive. I mean, these are I would say the plus we see for the plastic pipes. You can glue them. You can also thermal join them. There are a lot of fittings too.
And I've worked with, or at least my teams have worked with plastic pipe. And the thing I would back out on, say for example, and John Gross or Valley Sorrell, do you have any insights? I know that you've been in the design world for years. What are your perspectives on the benefits of plastic pipe?
Well, I think a lot of the things that Jaime mentioned are definite upsides. I know that in some of the locations that I've worked, the big challenge is the workforce that has the comfort to install them in kind of a mission critical application. A lot of the locations that I've worked on data centers here in the U.S. Have very strong union pipe fitter presences. And they are very good at making plastic piping more expensive to install than steel, because they can't employ as many welders in the unions when they do it. So there's some market forces there that sometimes will drive plastic pipe out of consideration. One of the other real challenges that I've seen is dealing with the thermal expansion and contraction of the piping, because it does have typically a greater coefficient of thermal expansion than steel does. So it just takes a little bit more consideration on the design side when implementing it, from what I've seen.
Any other comments or discussions?
Ali from OVH. Depending on plastic pipes, plastic pipes would be a good option when dealing with low temperatures, but going with temperatures higher than 40 or 45 degrees Celsius, plastic piping will not be a good option, because they will be thicker, complicated to be installed, and with expansion problems. So we shifted from plastic pipes to stainless steel pipes finally, and we are happy with now with stainless steel pipes.
Hey Ali, hi. This is Rolf speaking. Rolf,
Hi, Rolf.
from Asperitas. Hi. I would like to follow your remark up with a question to you regarding plastic piping, because we've looked into plastic piping as well, and one of the things that I've become aware of, there is like about 20 different types of plastic that are being used for piping. How generic should we take your remark from just now? Because I know for a fact that I have only ever tested one of those types of piping, so I have no right to speak on this. But how generic or how elaborate have your findings been?
Yes, we tested three types of plastic pipes. We tested PVC, and for about 10 years we had PVC pipes all over the world, and we tested also PPR, and which is using a clamping method, and we also tested fusion plastic fusion piping, and finally we went from 5 delta T Kelvin to 20 Kelvin, and return temperature was really high, and the plastic pipes didn't handle this temperature, and you had to increase the thickness of the pipes, and there we had the problem.
Okay.
Just one second. Just posted there a link of what we use actually is Aquatherm, and of course not every plastic pipe I think can be used for these applications for high temperatures. As Ali said, you have thermal problems. It depends on what kind of plastic pipe you're using, and we have very good experience with this. And well, I'm not sure if we can build like a standard surrounding, like benchmarking with this kind of pipes, and make it like very general. But well, our experience is good, and of course, we cannot obvious that the problem with corrosion is avoided now with these pipes.
So, I mean, what are the diameters you're working with?
Sorry, yeah, it's funny that you bring this one up, because this one is the exact same that we've tested a couple of years ago, and we're also quite impressed with. I can tell you that.
It's for obvious reasons, I guess.
And just to clarify,
we're not using it anymore, by the way, just for the record, right?
Just to clarify the disclaimer, Alfa Laval doesn't sell plastic pipe, so it's not that I have any interest.
And there are also some pipes, this could be it, that they're like prone to burst, like if it's outside. We also tested that a few years ago, but we found it very expensive.
Yeah,
Some of them also have UV protection as well.
that's where, particularly these pipes that were just shared by Jamie. These do, I mean, to make that burst, stainless steel, what we're standardized on at the moment, will burst more easily than these plastic ones.
Yeah, and I also add that some of the pipes, the Aquatherm in particular, which I'm a little bit familiar with, they offer different wall thicknesses, which gives you the ability for, you know, for different types. Well, first off, they typically don't burst like a steel pipe would, right? They expand, so you're more often going to have just the pipe gets bigger and then shrinks again, as opposed to going at the plastic deformation. And then additionally, you can get different wall thicknesses. I think, I believe Aquatherm calls it dimension ratio, but it's the same size pipe in different wall thicknesses, and that actually will affect the heat transfer from fluid to outside or vice versa. So you can actually control the amount of heat transfer and therefore the insulation that you need. So just another point on that.
Amy, what diameters have you worked with on the with Aquatherm?
Over 50, DN50. I mean, DN50, 100, 150, up to 200. I mean, there are different range of diameters, and even smaller. Also, even smaller. Also.
They connect with flange, or do you use just the? What I have heard with a lot of pipe plastic pipe solutions is the smaller diameters fuse fairly well. The larger diameters, you need to look at other ways of joining, especially if you want to disconnect and reconnect and verify it. Any thoughts on that?
On the plastic, you mean?
Yes.
Well, that's the funny thing. I think the link that Jamie provided says it all, right? If you just scroll down on that, it shows you how that works. It's a completely different technique than what you're used to with steel piping, but it offers great flexibility at the same time. It's very simple to cut through, put and weld it back together. So they call it welding, but it's not the type of welding you do with high temperature steel, right? This is welding as in you put a device around it that melts it back together. And like I said, I am actually a pretty big fan of this. I'm not in the infrastructure business. I do not put piping in place, but I loved seeing that in reality and operation. I'm not a data center operator, so I really cannot testify towards the practical use of it, but I have seen how incredibly easy and flexible it really is in terms of deployment, expansion, modifying it, and also the reliability and strength and the quality, how stable that is over time. So, but like, I have to also respect the real use experience that has been just provided by Ali from OVH, right? So that's, like I said, all I can say that this is what I've seen, and I was immensely impressed. We applied it, we used it in the completely wrong way. We used it for the smallest parts to get our standard piping or built-in piping defined, and that was years ago, and that was just a bad idea. So we're using stainless steel for that purpose, but for infrastructure purposes, I thought it was brilliant.
Hey, Don, aren't we getting off topic here?
We are getting off topic, and actually one of the things I was going to kind of wrap up here real quick is at the end of the day, I don't know that this paper that we're working on is going to take a position on what type of pipe you should use. That is something that will generally leave up to the engineering community. I would take a position on the issue of raising whether or not dew point is a concern and when and how to use dew point, and the fact that if you are working with materials that suffer from corrosion or could be subject to corrosion, you need to put in some sort of detection method to do that if you're using others. But the industry has billions of hours of operation of carbon steel pipes successfully done, and that needs to be respected as the industry. but the concept of adding other pipes, that might be a topic for another paper. This is just basically kind of looking at one concern was dew point. The other topic, and what I'm going to do, going back to the functionality of what we're going to look at in this, is that we will be, I'm looking for people to help edit or add discussions on the deal with dew point. The other topic I kind of wanted to address very quickly was the potential interest in, hold on a second here. We talked in the past, what I see in the vision of here was the concept of BIM deployment and requesting and mandating that, or not recommending that vendors of products that are used in the data center should provide some sort of content in a LOD level. And this kind of explained that a little bit more. Years ago, Bill Gates wrote this book, Business at the Speed of Thought. Right now, BIM, virtual design and construction, is creating the concept of data center construction at the speed of thought. What does that mean? Before BIM, this is how people used to put together pipe. They would take these little templates, they draw it, and it'd be one size, and you'd have to sit there and you'd end up doing stick belt and taking a slide from PCX. We looked at modular data centers where things are pre-designed and snapped together like kits, and they take a lot less time on the job site. And the concept we're looking at here with OCP is we're going to be adding liquid in an operating data center. And to do that successfully, you're going to want to have a perfect kit to snap together, minimum downsize ability to snap together. And that would require, or would benefit from, if all the components that are being used in the kit are already modeled to a high level of accuracy, then putting together a drawing or a solution and delivering this like a IKEA construction kit or a Lego construction kit would definitely make it a much smoother process. What are people's thoughts on this? Oh, by the way, I guess I'm not sharing something right now. I thought I was. So this is what I was looking at here. Any comments on the pros and cons of requesting that vendors or recommending that vendors have their products available in a BIM LOD 350? And I can explain what LOD 350 is if people want to know.
Don, this is a thing that comes up pretty often, and I think probably before you go too much further is that the format of that information might need to have some kind of standardization. I'm not sure if just knowing BIM LOD 350 is sufficient, depending on how the manufacturer did their drawings. Some people use software that is advantageous for manufacturing, particularly smaller pieces. Some companies use software that works better for the construction industry. So for example, SolidWorks versus Revit. And it's easy to say on a call like this, well, it's simple. It's just a transfer and you just, translate the knowledge. It can be really expensive because those various software don't necessarily talk to each other. So if we're going to continue that part of the conversation, and I think it's a must because that's part of the future, part of lean manufacturing and lean construction, and they have to go hand in hand. And maybe this is a forum to help forward that. Those two organization types aren't necessarily hand in glove right now. So BIM LOD 350 is still maybe too vague.
Yeah, so Jack, I would agree with exactly what you said, because I deal with that quite a bit, where we're putting together design models in Revit, and we're going looking for Revit family content in an RFA file format and we're getting SolidWorks files from manufacturers. And while you can go through the Autodesk software suite to convert those SolidWorks files into Revit 3D geometry, the 3D geometry is only part of the discussion when we're getting to LOD 350. And so I think the end goal, at least in the conversations that Don and I had, and that we've had kind of earlier on in the various meetings, is what's implied but needs to be explicitly defined is that we're talking about in a Revit format with parametric data contained within that file.
So what parametrics did you highlight as being most critical?
Well, so, when we're talking, it depends on what piece of equipment we're talking about, right? But I mean, fundamentally, from a selfish standpoint, we're talking about, connection sizes, we're talking about flow rates, pressures, temperatures, all those MEP characteristics or parameters that are used to design the system. So, on the power side, it would be, voltage, frequency, FLA, MOCP, those types of things. And I can give you a more comprehensive list offline, Don, because it can be a fairly extensive list. But I mean, fundamentally, I think that's what we're talking about. I mean, with the RFA, there's two main components to it. There's the geometry, and the geometry needs to be correct to the product. And then the other piece of it is the parametric data that goes into the calculations and the BIM modeling piece of it to tie everything together, tie the intelligence together in the design documents.
And if I may, John, I'll add to that there isn't, well, and this is a point that Jack made earlier as well, but there isn't consistency. I mean, the concept of, or the reality of having some SolidWorks models and other types of models and then Revit coming together is difficult to start with. But even within the metadata associated with an RFA, I find pretty wild inconsistency with the way that the metadata is added. So it would be great if the flow rates and all of the items that are technical parameters which affect a system of a given type were very standardized, but they're not, or at least they're not even within Revit as far as I can find. And I don't know of a good standardization that exists elsewhere. If you look at IFC, which is intended to be an open standard for this, for BIM type models, that's hard to even find any standardization in. So I guess what I'm doing is echoing that Jack's sentiment, which is to say that there isn't a good path right now from A to B if you have disparate types of file formats, and then data formats, and then inconsistency in the data that's actually included in the models. So it's not a panacea at this point. It makes life easier in a lot of ways, but it's not a panacea.
No, and I agree, and I think there are best practices that are out there for defining that parametric data. There are absolutely standards and the right way and the wrong way to do things, such as making the electrical and the piping connections within Revit to where the flows and the pressures and the velocities propagate through. They're not really well published, to your point, but the information is definitely out there. What I can do, I've got a BIM consultant that works with me on a regular basis, where basically all they do all day, every day is BIM development and whatnot. And they're a consultant to a lot of folks out there in the industry, and I can reach out to them and see if I can get them to maybe help us put together some of the content if we want to, kind of push towards trying to come up with something that, you know, that could be, you know, really just kind of some guidance from OCP about how to put these RFA files together to help the design teams.
That does sound very advantageous, actually, if they're willing to share that, you know.
Well, this is an area where I truly think that ACF and OCP can take a leadership role in our industry. The industry is already heading in the direction of BIM and prefab becoming much more integrated. And I know that sounds trite. Anyone who's been in the industry long enough, if you've been here for a couple decades, you've heard a couple decades of presentations where BIM and prefab are the vision of the future. But the reality is BIM really didn't get defined until 2013, and it takes a while for it to percolate. But if you talk to the Nancy Novaks of the world and the other data center leaders on the technology or data center construction, this is where the industry is heading. OCP has an opportunity to take a leadership role and give some definition to via recommendation. I do appreciate Jack's concern that there's a cost to this, but I believe that if the requirements are clearly defined, and that's probably the biggest risk, is responding to something that's not defined, wasting money on something that's not clearly defined, and then finding that you have to do it all over again. Right now, when Jack's products or when someone's products, when John Gross uses somebody's products, he has to spend money on having them modeled to fit in his BIM design. Is that correct, John, or what are your thoughts? When you have, if you're putting together something and the customers ask for a 350 deployment, a BIM 350 deployment, what are the costs to you if you don't have the stuff in content?
Oh, they can be tremendous. I did a project a couple years ago where I was tasked with LiDAR scanning an existing chiller plant and generating a BIM 350, LOD 350 model of that plant. And I would say that out of the entire project, I probably spent 2 to 2.5 weeks, nothing but creating Revit families to plug into that, where I got the geometry from the manufacturer, but there was nothing else useful that came from the manufacturer, whether they sent me a SolidWorks file, or in some cases, they sent me Revit RFA files that were so poorly compiled that they were useless other than the dimensions and the shape of the element.
Okay. So at this point, the key thing I'd like to highlight was a couple things. Number one, many of the vendors on this call, I know for a fact, have never heard the term BIM LOD 350 until they started hearing it on these calls. Okay. But I would like to get a group together to actually help, and sounds like, John, you're going to be part of that, maybe Jack and some others. Let's come up with, if we are going to recommend, and again, we're not requiring, we're recommending that a Revit modeling be available, that we define it well enough so the industry can absorb that. Because what I am finding is many people like John Gross are actually internalizing the cost of vendors who don't have product that's already modeled to appropriately. And if vendors do take the cost to model it appropriately, if OCP gives that guidance on what to model, that would make an advantage for a vendor. You have two vendors with the same product. One product is already modeled and ready to plop into a drawing. The other one requires 3 days of and I don't know, John, how long does it take to model somebody's product?
I mean, it depends on what it is, but the last time I did a water-cooled centrifugal chiller, that was probably, to get it completely right to where everything was working, it was 8 hours worth of billable work.
Okay, so right there, if you're looking at the preference of what centrifugal chiller John would use, all things being equal, having one that was ready to plug into his drawing would save him 8 hours of billable time and schedule. So that's kind of where we're going with this. Again, I don't want to be too strident on this, but I think it's an area that deserves to be looked at. And the other thing I would also say is when you look at the success of delivery of data centers where products are precisely modeled like this, it can be mind-boggling how quick a data center can be built if all the products, if the entire solution is a 350. John, do you want to give any thought to that, or anyone else on the call want to give a comparison of once you do get beyond the concept of doing the complete modeling, does it really save time on the job site if you are doing a 350 versus a stick built that doesn't have that level of modeling?
Well, so I mean, the best example that I can give you, Don, and it's not a data center example because I'm still seeing this is new to be adopted within the data center realm. But I do this type of stuff a lot in chiller plant work that I do. And I did a job a few years ago where we LiDAR scanned an existing 2,500 ton chiller plant, and we were doing a chiller replacement, replacing the entire pump header because they were dedicated pumps, and we were going to headered pumps, and so on and so forth. And we did the LiDAR scan, then we designed everything to LOD 350. We turned over the design model and the base building LiDAR scan to the mechanical contractor, from which they could generate their piping shop drawings and their piping spools. They prefabbed everything except for the last connection of the headers just to give themselves some room on dimensional tolerances and whatnot. And we did the entire chiller replacement, pump header replacement, et cetera, during a single 48-hour shutdown of the chiller plant. And that was, wrecking the old stuff out, putting the new stuff in, making the connections, insulating it, pressure testing it, and turning it on. And there's no way that would have been possible without doing that level of 3D coordination ahead of time.
Great example. I've got some examples also along those lines, but everything that could be done to reduce job site man hours is huge in today's data center world. And that definitely includes not just the COVID effect. If you can have fewer people on the job site, fewer people that are having to do face-to-face, hand-to-hand construction, you meet a lot of goals that our world is trying to drive toward. Obviously, one of these days we're going to be outside of COVID, but even then we're going to still be looking at how to build fast, how to deploy quickly. And the case in point, the business model that we're looking at with these discussions here is, in many cases, someone decides that they need a new application, a liquid-cooled application. And when a boardroom decides that, they generally want it within the next couple of weeks. The ability to deploy that quickly is something that would be greatly enabled if all the content was available in a high level accuracy and highly defined. I don't want to get this too much of a lecture, but I do appreciate there's a cost associated with this, and vendors who are currently modeling things for their own purposes, but not necessarily for construction purposes, might be hearing this as being an additional cost to their product. The reality is that cost exists regardless of whether or not they incur it. It does exist in the construction process, and the best place to own it would be at the vendor level if possible.
If I may add, and I think I've said this before on this call, I agree. I think this is a great way forward, and it's the future. And certainly mechanical is quite a bit ahead of electrical as far as BIM is concerned. But my appeal to manufacturers, including my own, I am with Vertiv, and we have a lot of products that we have done in BIM and offered them out to the industry. And they're varying quality based on how they were done. But my piece of recommendation is something that John alluded to earlier. John can get in there and do just about anything with BIM, I'm sure, but he uses a consultant for a lot of that. If you're a manufacturer and you don't have a BIM, a Revit specialist on board, it's highly recommended that at least my piece of advice here would be don't try it yourself. Bring in a consultant, spend the money. It'll be worth it for your clients. and it'll be worth it for your engineers that deal with your gear in the future, because there's not much worse than a bad model from a vendor. And I think John probably would agree with me on that, although I don't want to put words in his mouth.
Oh no, I absolutely would. I've spent plenty of time going around trying to find workable families from manufacturers, only to find that as nice as the geometry looked, everything else was kind of worthless. And I have talked to some smaller manufacturers before that have their SolidWorks files, and that, like I said, the geometry of that stuff can be imported into Revit, and it's actually a fairly quick, it's a couple minute file load save as type thing through the Autodesk suite to get there. Not really a big deal to get the geometry right. It's everything else. And the consultants that do this stuff every day, they can knock that stuff out in a few hours per piece of equipment. But a lot of times, the consultants don't have a whole lot of time like that kind of baked into, we don't have that baked into our fee or our schedule when we start having to do it on more than just a one or two device, situation.
Okay. So I appreciate the discussion today, and we're getting toward the final minutes, and I apologize for having lost the first couple minutes, having to reboot my system, and I will make sure next time that I'm signed on. I thought 5 minutes early, but things just locked up on me. I'd like to move forward, and please, if people on this call that want to participate, you can participate a couple ways. You can just go online to one of those links that I send out all the time. You can open up the link and you can make comments. And if you make comments on the document, I'll add you to the editor's list or things like that. If you send me an email saying you looked it over and you liked it, I'll add you to the reviewers list. The power of this document improves with greater review and greater acceptance by the community. But on the other hand, I do need some people to do some heavy lifting. And one area would be to help. I think it's very important that we come up with a really good description of what we're asking for in terms of modeling content. We'll take that offline, and John Gross, Jack, myself, and anyone else that wants to contribute to that would be useful. And I'd love to hear from any vendors that feel that this is not a worthwhile effort, or want clarification of what it is we're really trying to talk about. Because if this is the first time you heard of BIM LOD 350, it's kind of like, wow, what is that? So anyhow, any final comments to throw in before we wrap it for today?
Hey, Don, this is Archana. You had mentioned 2 different work streams. So I have added the one that you posted in the chat, that Google document, to the wiki page so people can access it from there. But if you could send me the link to the other one, I can also add it there. And then that way people have another place that they can access it instead of, looking at invitations and emails.
So Archana, thank you for your gracious support. As much as I talk about things like BIM LOD 350 and Google Docs, I'm learning as I'm running. Okay.
No worries.
So a month ago, I didn't know how to do Google Docs, and I'm learning it slowly but surely on how to make sure that it has permissions. Everyone should be receiving these in emails that I've sent out, but to Archana's point, one of the key areas to find this, not just in my emails, is it should be part of our wiki. And yes, Archana, I will send you an email right after this that has both links. And again, I would love editing. I'd love comment, participation. Part of this discussion this week came because someone called me over the week and brought up these questions to me. I saw comments about, why are we looking at LOD 350? That has nothing to do with mission critical. And I think we've kind of covered that today. I saw other comments talking about what is condensate concern. And so we covered that today. I think these are very important, but they're very technical topics that need a deeper dive and discussion.
So one more thing, Don, there are several conferences that you are also participating in, and I'm obviously sending your abstracts off to conferences as well. So there's 2 that have been accepted. One is the DCD Keeping IT Cool event that will be happening in July. And then there is also the Data Center World conference that is coming up, I think in August, and their deadline is today, I think, for submitting abstracts. So if anyone in the community is interested in submitting abstracts, that, you know, their deadline is today. And then the Data Center World UK is also in late July. And I believe all 3 of these are virtual events right now. So just wanted to throw it out there.
So I did submit last night, but I did not tell you what I did.
No worries.
But I do want to talk to you about that, because maybe offline, and we'll stop the recording or something like that, so I don't get impeached.
Hey,
so
Don,
anyway,